Hello and welcome to our lesson on speeding up a chemical reaction. There are 5 ways we can change the rate of reaction. We can change the temperature, we can change the pressure, we can add a catalyst, we can change the surface area, or we can change the concentration. We will go into more detail about each of these in further lessons, but for now I just want to go through the basics. The first one then is temperature, and the core concept behind temperature is energy. Temperature is a measure of how much thermal energy the reactants and products have. The more thermal energy a particle has, the more kinetic energy it has. If you remember, kinetic energy is movement energy. So if I increase the temperature and I give it more thermal energy, the particles will have more kinetic energy and they will move faster. This means they are more likely to collide successfully, more frequent successful collisions. For pressure, the key word is going to be space. If I make the space smaller, the particles are going to collide with each other and with the outside of the container more often, more frequent successful collisions. So less space is more pressure and less space is more collisions. Surface area is about how much of the surface or how much of the reactant is in contact with the other reactant at any one time. It's worth remembering that the smaller the pieces, the larger the surface area. And again, we'll come back to this in another lesson. But the smaller the pieces, the larger the area, surface area, and therefore the more frequent successful collisions. For concentration, the key word is crowded. If you look at the pictures down here, the diagrams, this one here, there are not many or not as many reacting particles in a given volume, whereas here there are more particles in the same space, so it's more crowded. If you look at this picture up here, this might be something more familiar to you. This is concentrated versus dilute Ribena or whatever it is. So here there are more, if you will, flavour particles in the same amount of space or the same volume. You'll notice there is the same amount of liquid, that's the volume, there's the same amount of liquid in each of these glasses. The difference is how much of that liquid is the Ribena. And here there are many more Ribena particles, whereas in here there are many more water particles. So the number of particles, reacting particles in a given volume is concentration, and the more concentration, the more frequent, more particles, and therefore the more frequent successful collisions. Okay, so I thought it would be worth looking through this question that we do in class, because there's a lot going on, and I think it would give you a really good idea of what you're looking for in exam questions. So I'd like you to pause the video and read this information and just start to think about what each of these numbers actually mean. What's it talking about? Which one's the temperature? Which one's the volume? Which one's the concentration? Is there a catalyst? All that sort of thing. Okay. So it says here, the graph shows the progress of a reaction between 50 centimetres cubed of 1 molar acid and 0.2 grams of small marble chips at 20 degrees. Okay, so that 50 centimetres cubed, that is volume. That is telling us how much liquid we actually have, okay? And we would measure that using a measuring cylinder, okay? 50 centimetres cubed. The 1 molar acid is concentration, and you should have remembered that from Unit 3, looking at concentration and looking at acids and alkalis concentration. Okay, here it says small marble chips, so that's talking about the surface area. So if they're small, you're going to think, well, they've got a large surface area, so it's going to be a faster rate of reaction. And then of course 20 degrees, hopefully you've got this temperature. Okay. It then says, in each of these cases, the reaction is repeated with different conditions. So they're going to be comparing this version with other conditions. So they're going to change something. And at the end of the experiment, there's plenty of marble left over. That's just so you know that you're not running out of reacting particles. Use your understanding of collision theory to sketch in the graphs for the repeated experiment. So I'm going to take you through each of these and see what we can do. Okay, so I've got the first bit at the top here that we've just done. Okay, so let's just re-highlight. So I've got 50 cents, that's the volume, concentration 1 molar, 0.2 grams of small marble chips, and 20 degrees. Okay, and then I'm comparing it here. So this time I've got 50 centimeters cubed of acid, that's the same. 1 molar, that's the same. 0.2 grams, that's the same, of marble chips. Doesn't say whether they're small or large, so we'll assume the same, at 30 degrees. Okay, so 30 degrees is obviously higher, so I'm going to have a faster rate of reaction. So how would I draw that? Well, if I change the colour here, I want to be a red colour. Here we go. It's going to be faster, isn't it? Because I've increased the rate of reaction. Higher temperature, so I'm just going to do it a little bit higher, a little bit faster. It's going to slow down sooner, and most importantly, it's going to finish sooner. It's running out of reactants quicker, so it might look something like that. Okay, so this one here then, I've got 25 centimeters cubed. Right, that's half the amount of acid. Still the same concentration, still the same amount of marble chips, and it's the same temperature as it was originally. Okay, so I've only got half the amount of reactants. Well, you would think, well, okay, it's not going to make any faster or slower. I've just got half the amount, so I'm actually probably going to make half the products. So it's probably going to start off in a similar way, but it's just going to only make half the amount. That could be a little bit lower down, couldn't it? But it's about half the amount. Hopefully that makes sense. I don't have as much, as many reactants. I don't have as many ingredients. I can't make as much. Okay, so for this one here, I've got 50 centimeters again, so that's the same. 1 molar, that's the same. One big, okay, one big, 0.2, it's the same amount, but it's one big marble chip. And it's 20 degrees. So the thing that's changed then is the one big marble chip rather than small marble chips. So surface area, the smaller the pieces, the faster the reaction. So this is a big piece, it's going to be a slower reaction. So I'm going to start off shallower. It's going to take longer, but I am going to make the same amount because I've got the same amount of ingredients, also the same amount of reactants. I've got 50 and 0.2. So it might look something like that. So it's slower, still follows that same curve just about, because it's difficult to do it on the computer. Same curve, but it finishes slower. It still makes the same amount though. Okay, this one here, I've still got 50 centimeters, still 1 molar. It's 0.2 of marble chips, doesn't give me a size, and it's 10 degrees. Okay, so it's colder. So I've got less thermal energy, excuse me, less thermal energy, so my particles are not going to move as quickly, so it's going to be a slower reaction. Okay, so am I going to make the same amount? Yes, because I've still got 50 and 0.2, so I'm still going to make the same amount. It's just going to be a bit slower, so I'm going to start off shallow. Takes a bit longer, but it does make the same amount by the end. Okay. Okay, this one here. Okay, so I've only got 25 again this time, so I've only got half the amount of that reactant. Still same concentration, still got the same amount of marble chips, but that's not going to make any difference because I've only got half the amount of acid, and it's at 40 degrees. Oh, they've changed two things. Okay, so I can only make half the amount because I only have half the reactants, but it's going to be faster because it's at 40 degrees. Grief. So it's going to be faster, go over very quickly, but I'm only going to make half the amount. Something like that? Looks about right, doesn't it? Okay, so with this one here, 25 centimeters cubed, I've only got the half amount again. The same concentration, same amount of marble, but we have a powder and 20 degrees. Okay, so the powder means I've changed the surface area. they're very small pieces, aren't they, powder? So the smaller the piece, the larger the surface area, the faster the rate of reaction. So I'm going to have a fast reaction, but I'm not going to make as much because I don't have the 50, I only have 25. So again, it's going to be faster. It's going to be over very quickly, but I'm going to make just half the amount because I only have half the ingredients, or sorry, reactants. Okay, so that's hopefully giving you a bit of a feel for where we're going with this and kind of how that makes the graph change. You'll notice the shape of the graph stayed the same. You have that kind of that curve that it's faster at the beginning, it slows down, and then it stops. It just depends on when and where that actually happens. But over the next few lessons, we're going to look at this in a bit more detail. So that's the end of this lesson for today, guys, and I'll see you next time.